Hello everyone. In this video, I have brought another important topic about lenses from our chapter Light, Reflection and Refraction. So let us talk about spherical lenses, and then we will also talk about different terms which are required to understand so that we can talk about ray diagrams in case of convex and concave lens. So let us take the topic spherical lenses. So we can say that it is a piece of transparent refracting material. Transparent refracting material, and this refracting material is glass, and it is having two surfaces, and both the surfaces are spherical. Here the types of spherical lens is first one, that is convex lens. Convex lens is also called converging lens. The second one is concave lens, and concave lens is also called diverging lens. So we can just draw the diagram of convex lens. It is having bulge out surface. Both the surfaces are bulge out. This represent your convex lens. Another lens we will draw. Here it is your concave lens. So when I say about convex lens, this lens is thick at the center and thin at edges. Regarding concave lens, here it is thin at the center and a little thicker at the edges. We can also see that the convex lens is called converging lens and concave lens is called diverging lens. Let us move further to understand about the terms associated with the spherical lenses. So first I should draw both the lens. Here is your convex lens, and if I extend this one as a part of sphere, I can get the center of the sphere. That will be the center of curvature this side. If I extend this part as a part of the sphere, I can get the center of sphere. That will be the center of curvature. I am naming it as C1 and C2. Here it will be A, let it be P here, and I am indicating this surface as P and this surface as Q. Another lens I should draw first. Here I am drawing your concave lens. This is the concave lens. If I draw the sphere part completely, I can locate the center of curvature this side. If I draw from here, I can locate the center of curvature here. Let it be C1 and C2. This lens will be AB. This surface is P and this surface is Q. Now, what are the different terms which are associated with the spherical lenses? The first one is aperture of lens. So, what does it mean? Aperture of lens. It is the diameter of the circular edge. Diameter of the circular edge of the lens. So, what is the aperture of the lens? This diameter AB. This diameter AB is the aperture of the lens. The second term is your center of curvature. Center of curvature of lens. So here we will see that a lens, either it is convex or concave, having two spherical surfaces, and these spherical surfaces are the part of the sphere, and the center of the sphere, we will say center of sphere, are called center of curvature, and here we have denoted with C1 and C2. Now we have the third term, which is here we have to understand, that is principal axis. So principal axis is your imaginary line. It is an imaginary straight line. That is passing through center of curvature of the two surfaces of the lens. That is what the principal axis. we have the fourth one. Before fourth one, I can just locate. This is what represent your principal axis. Here also this line indicate your principal axis, and it is also passing through the optical center C. Optical center C. Now we have the fourth term, that is optical center. Optical center of the lens is a point on the principal axis of the lens, such that the ray of light which passes through optical center without any deviation, it goes through it. And it is denoted by C. This is here the optical center. If a ray of light passing through optical center without any deviation, it passes through it. When a ray of light passes through optical center without any deviation, it passes through it, even for concave lens or even for your convex lens. Any ray of light passing through the optical center without any deviation, it goes through it. Similarly, here we can show no deviation is seen when a ray of light getting incident at optical center of the lens. Any deviation is not seen here, and without deviation the light rays passes through it. Moving further in the topic, let us take the convex lens first. So here we have a convex lens, and in convex lens we will talk about two things. One is principal focus, and another thing is focal length of the lens. Principal focus is denoted by capital F, and focal length of the lens is denoted by small f. Let us draw the ray diagram first. Here we have the principal axis. Here I am drawing a convex lens. This is a convex lens. If I extend this part of the surface and complete the sphere, I can locate the center of curvature. Here also, this side also, I can locate the center of curvature. This, let it be C1 and C2. Here is the optical center. X and X dash is the principal axis. Now from the midpoint between C1 and C will be the principal focus F1. The midpoint between optical center and C2 will be the principal focus F2. So let us see here that a convex lens is having two surfaces. This is the first surface, you can see, and here is the second surface. So it is having two principal foci as f1 and f2. So first principal focus is f1 of a convex lens is the position of a point object on the principal axis of the lens for which the image is formed by the lens is at infinity. If I consider an object here which is placed at the principal focus of the lens, that is first principal focus, so in this case I will see that the light rays after refraction it becomes parallel to the principal axis. So these light rays will of course never meet, and so image formation will take place at infinity. So regarding first principal focus, we see that it is a point on principal axis, a point object, and for which the image is formed at infinity. Here the first principal focus we have denoted with f1. Now let us see that the distance of first principal focus from the distance between C and f1 is your focal length 1, distance between optical center and principal focus 1. This is called the focal length of the lens, the first focal length of the lens. First focal length of lens. Now let us draw another ray diagram representation. Here I'm making a convex lens having two surfaces, that is bulge out surface. If I extend the part of the sphere, I can locate easily the center of curvature. This is optical center, this is center curvature 2. Here this side I can see, here it will be center of curvature. The midway between C and C1 is f1, that's principal focus. The midpoint between C and C2 is the second principal focus. Now if I talk about f2, that is second principal focus, so it is a point, it is a point of on the principal axis where the image formation take place when object is at infinity. So these objects, let it be the incident light rays, are coming from the object and falling on the refracting surface. After refraction, the light rays passes through f2. So these rays will meet at f2. Here the image formation will take place. When these light rays are coming parallel to the principal axis from the other side, after refracting from the surface of the convex lens, it gets refracted and passes through the point, that is f2, where the image formation take place. That is the second principal focus. Now what about small f2, that is second focal length of convex lens is the distance between optical center and second principal focus. No, it is the distance between optical center and second principal focus, that is second focal length, f2. So this is what about principal focus and focal length of the convex lens. Moving further in the topic, let us now take concave lens. Similarly, we will talk about concave lens, principal focus, and focal length of the lens. So for this we need to make two ray diagrams. Firstly, I will draw the ray diagram regarding concave lens. Here I have the concave lens. If I extend this part of the as a sphere, I can locate the center of curvature. Here this side also I can locate the center of curvature C. Here it is optical center, it is C1, it is C2. The midpoint between C and C1 is pencil focus f1. The midpoint between C and C2 is pencil focus f2. Another diagram I can draw. Here we need to draw a concave lens. Here we need to draw the concave lens. This is the center of curvature. Here is the optical center. Here it will be pencil focus 2. This will be center of curvature. This will be optical center. Midpoint between C and C1 is pencil focus f1. Now let us talk about f1, the first principal focus. Here we will see that in case of concave lens, we used to see that when the light rays are parallel to the principal axis and focusing on the or getting incident on the refracting surface of the concave lens, they used to get diverge. They diverge away, but the diverged ray appear to be coming from the principal focus. That principal focus used to be where the image formation will take place. So here we have seen that light rays are parallel to the principal axis. After a refraction, they diverge. These diverged rays appear to be coming from your principal focus f1, where image formation will take place. So this f1 is the principal focus. Now what is small f1? This small f1 indicate the focal length. The focal length, that is distance between optical center and principal focus f1. Now in the second one, let us see when the light rays are coming the source of the object, and they are getting incident on the refracting surface somewhere in this way. After refraction it becomes, and these rays becomes parallel, as we can see that these rays are getting incident on the refracting surface, and they appear to be passing through the second on the other side principal focus, but after refraction they becomes parallel to the principal axis. They become parallel to the principal axis. So here it will be your principal focus f2. So we see that the principal focus of a concave lens, this one, this f2, this principal focus of the concave lens is the a virtual position on the principal axis, for which the image formation will be at infinity. And regarding the focal length, the focal length of the lens, that is f2 here, is the distance between optical center and principal focus f2. So this is what we have come across about different terms which are associated with spherical lenses, and initially we have also discussed about what is spherical lenses, where these lenses are utilized. We already have an idea that lenses are used in spectacles to magnify and to visualize the object. Lenses are also used in photographic cameras, microscopes and telescopes, and there are many other instruments where the lenses are used. So this is what we have come across. Lenses are having two spherical surfaces. It could be both surfaces could be the bulge out surface. Both surfaces could be the bulge in surface, not bulge in, the bent in surface, and it could be a special type of lens that is having one bulge out and one is bent in surface. So it is about two types of lens, that is convex lens and concave lens.